Exam 3, which covers chapters 3 and 4, review key. Number 1, solve the system of equations by graphing. Clearly state the solution to the system. If the system does not have a solution, state no solution. Bonus, we're going to state correctly if the system is consistent, which means it has at least one solution, or it is inconsistent. So for graphing, what I'm going to do is I'm going to draw my XY coordinate system. And this is similar to what you would do on your paper. If you want to use a ruler, you can use a ruler. Now, some of you actually brought graph paper to the last test, and that was really nice. But it is not necessary. So there's my XY plane, and I'm going to mark on there by 1. I'm going to go 5 in each direction. And try to be neat so it looks fairly consistent as I can with a hand-drawn graph. And then I'm going to draw in or write my equations. Now the first equation, the one I'm going to highlight in pink, I can graph right now the way it is. Y is equal to negative 1/2 x plus 5. And so the y-intercept is 5, and my slope is negative 1/2. So I'm going to go down 1 and then to the right 2. This just like what we did in chapter 3. Now I'm going to take my ruler and I'm going to graph the pink graph. I'm going to draw it in. I like putting points on the graph, my lines, because they go forever in both directions. Now for the second line, I'm going to highlight this one in green. That's going to be my green line. I do have a little bit of algebra that I have to do because it's not in a form that I can readily graph. I could find my y-intercepts, I could find points. But if I were to add y to both sides, and then subtract 2 from both sides, mainly I am solving for y. Okay, y is equal to 3x minus 2, and that'll be the graph that or the equation that I use to graph the equation. So I'm going to go ahead and grab some green ink here, since it's the green highlighted equation, and I'm going to first plot a negative 2 on my y-axis, and then my slope here, you remember it's 3, but it's 3 over 1. So I'm going to go up 3, 1, 2, 3, right 1. And then I'm going to go up 3, 1, 2, 3, right 1. And I'm going to draw this in, intersect it, and I already see that point. Remember, the solution to these equations when we graph them is the point of intersection, because the line represents all the solutions for that equation. And if I were to look at my solution, I would count over 1, 2, so I know my x's is 2. I want to get to this point here, and I'll just highlight that point right there. That's what I want. And then I go up 1, 2, 3, 4. So 2, 4, this is my ordered pair, and that will be the solution to the equation. Now, you can go ahead and check them in the equations above. And for the green equation, if I put 2 in for x, I get a 6 minus y, which is 4. 6 minus 4 is 2. That checks for the first equation. And for the second equation, when I put x or 2 in for x, negative 1/2 times 2 is a negative 1, and negative 1 plus 5 is 4. So it definitely does check for this system. Number 2, solve the system algebraically. Clearly state the solution to the system. Oh, one thing I guess we forgot to do, sorry, is I forgot to state, let's go for those bonus points, right? Since we have a solution, our bonus points, you can earn up to 1 bonus point per question. This is a consistent system because it has a solution. Okay, bonus. All right, now we can go to the next one. But we want to solve this system algebraically. And if it doesn't have a solution, we're going to say no solution. So algebraically, when I look at this, I can use either substitution or elimination. And what you want to do, we may do this differently, but how I would do this one is that I'd use substitution. The reason I'd use substitution is we already have x solved for it. So I'm going to go ahead right to step 2, and I'm going to solve, or I'm going to substitute 2y plus 1 into the opposite equation for the x. So I'll write 2 times our x, but our x is going to be this 2y plus 1, and then plus y is equal to 12. So we end up with 4y plus 2 plus y is equal to 12. I'm going to subtract 2 from both sides. And I end up with 5y, because I can combine those y's, is equal to 10. Y is equal to 2. All right, so I already have part of my solution. And now what I'm going to do is I'm going to find x. And I'm going to find x by substituting this 2 into the green equation. Okay, so I started with, you can use either, but this one's already nicely figured out because x is equal to 2 times, I'm going to replace the y right away. Y is a 2 plus 1, which gives me a 5. All right, so with that, I have my the two pieces I needed. I needed y is 2, I needed x is 5. I can state my ordered pair as, remember, it goes x and then y, x and then y. Now this is a consistent system, and I'm going to take a moment just to check my work. I always check my work as I go along. All right, top equation, the one that's already highlighted green, 2 times y, which is a 2. 2 times 2 is 4 plus 1 does equal 5. Okay, so it does check. If you need to write it out, please write it out. And then the second equation, the equation that is not highlighted, 2 times x, so that'd be 2 times 5, which is 10, plus y, which is 2. So 10 plus 2 is 12. It definitely does check. Circle our answers because we're proud of them. And that would be the solution with the bonus point for saying it is consistent. Let's move on to number 3. Solve the system algebraically. Again, if it has no solution, state so. And then we're also going to go for the bonus point here too. Now with this system, I see that the top and the bottom are both in that ax plus by equals c format. So I'm going to use elimination, and I'm going to focus on my x terms right here, because they're close to being opposite. I would do 4 and a negative 4, and the top is already this negative 2. So I'm going to take this equation, the top one, and I'm going to multiply by 2, which gives me negative 4x plus 6y is equal to 6. So I multiplied every coefficient in the top equation by 2. The bottom equation, I'm just going to bring it along because I already have that nice 4x. And it's nice because it is the opposite of negative 4x in the other equation. And once I do that, I'm just going to put my line under and I'm going to add. So we know that the x's cancel. That was our goal, right? We focused on getting rid of our x terms. I then have a 6y minus 6y, which they do cancel, right? Completely cancel, so I get a 0. And on the right, 6 minus 2, I get a 4. Well, we know that this here, that's nonsense. That does not equal. And so since it's nonsense, we say this is no solution. There is no solution for this equation. That means it is our bonus point here. It is inconsistent because there is no solution. So if it was something like 0 equals 0 or 5 equals 5, that's when we would have every solution, infinitely many solutions. But in this case, it is nonsense because 0 never equals 4. Never, never, never. It's nonsense. It's a very technical word, but we have no solution and the system is inconsistent. Now